we are, and just did, collect the first review test. That is from the computational review. And this is a pattern that we will follow on a daily basis. Tomorrow, I will be collecting review test 2 at the beginning of the hour. Usually, I would return review test 1. Since we have some people who are still not able to turn in review test 1, I won't return it tomorrow. I'll wait until people get books and get caught up, but we need to do that immediately. This isn't a case where you have a week to get books. You need them right now. So one of the things I wanted to start this morning was to give you an idea of how can you get some help. So what we're going to do is go to the document cam at this point, and this is the URL that you need on a computer to get to a web page. So we'll leave that up on the screen while you write it down. You need to write this down. A URL. That stands for, by the way, Uniform Resource Locator, which you probably didn't really care about. Now the CC stands for Community College, CA for California, US for the United States, and the JC URL is my name. Somebody yesterday when I gave that, you meant the MJC URL, and I said no. By the way, that would have been my sister's name. But at this point, just J. Curl at the end. Now what that's going to do is put you onto a web page, and I'm going to bring that back so you can see it here in just a moment. So we're going to come off there, and I'm going to switch buttons up here, press another button, and this is what you're going to see. It's a splash page. Now it doesn't read as well there as I'd like, but I'm going to isolate the lower left-hand corner. Math 10. That's going to bring you to, when you click on that, and you can do this, by the way, in the library, Founders Hall 124, and this brings you to the Math 10 homepage. Now there are some things here that I want you to be aware of because they're going to be useful to you. I'm going to come to the left side, and you will note extra units. Now this is the collection of what I first wrote for this class in the first version of the book. The titles are strange. Schizophrenic Rabbit, The Great Chase. Strange sounding titles. Some of them familiar. The counting unit is in this particular presentation. And something we're going to talk about today, Fibonacci numbers, is in that unit. And another thing we're going to talk about today called phyllotaxis is in that unit. And you can go back and see what was originally published. So those are extra units. And you can't print them, but you can read them. Interesting, this summer, Sarah and I went up to celebrate an anniversary in Yosemite. And we were in the Ansel Adams Gallery in Yosemite. And Ansel Adams was a very famous photographer, particularly of the Sierra and Yosemite. And when I first wrote this material, I wrote a letter to Ansel Adams and asked him if he would allow me to use one of the pictures he had done, and he was very generous about it. And the original picture I had found in a postcard called Eucalyptus Leaves and Pine Cones. And so I went to the Ansel Adams Gallery this summer saying, have you still got that? No. They had never heard of it. But you get a rare opportunity to see that photograph, and perhaps I should take time to do that. I didn't do it in the last hour. Just dawned on me I could do that. Okay, I just clicked on that link, and what I'm going to do is come down to what I think is going to be this link. Okay, let's try this. At the top of the page is Fibonacci numbers. Now notice, Googles and Googleplexes, we talked about that yesterday. The golden mean, something we're going to talk about today. Fibonacci's numbers, we're going to talk about today. The geoboard sounds like a skateboard, but it isn't. I'm going to click on Fibonacci numbers. I've got to ask Enza, what sign do you give for Fibonacci numbers? Ah, spell it. Okay, here I thought you were going to tell me something about... I'm disappointed. Now, there's a picture that goes with this unit, because this unit is about a very special sequence of numbers, and that doesn't come out as well as I'd like, but that's pictures of a rabbit, or of rabbits. But what I'm going to do is scroll down here and see if I can get the photograph I want. I think it's in this unit, but I'm not 100% sure. Ah, that's not looking good. So it may be in the phyllotaxis unit. So what I will do, Debbie, is come off there, and rather than bore everybody for a moment, I'm going to come back to phyllotaxis. I want you to see how this is spelled. There we go. Phyllotaxis. And palindromic numbers and the Great Chase. Those are some neat titles. Used to blow people away with those titles. I like that. Okay, now we're going to come to the unit here. And this is a thumbnail sketch of that picture. There it is. That's a pine cone. And that's going to be very important. So let me scroll down. Debbie, you can come off there for just a moment while I search for the... There it is. Now this, let's see. Okay, let's try it, see what we get. Wow. Now I'm going to scroll a little bit so you can see it. Yeah, I've got the resolution on this so you can't see it for all its... There are the eucalyptus leaves at the bottom. And then you've got a pine cone sitting on them. And I'm going to go up to the top. About there. You see the pine cone now? Pine cone and eucalyptus leaves. Now that has something to do with numbers today. And we're going to come back to that. So let me show you this list of numbers. 1206. Now I mentioned to you yesterday that Leonardo da Pisa in 1206 wrote a book called Liber Abaci. And in that book he introduced the Hindu Arabic number system. These 10 digits that we use to write a number. That was the first time. And he also had a problem about rabbits and how rabbits multiply. And here is the sequence of numbers that came out of the rabbit problem. Okay? 1 and 1. Now he said this. You start out with a pair of rabbits and they take 1 month to mature. And then they take a month to create another pair of rabbits. So the first month you have the pair, second month you still have a pair. But the next month, that first pair you had has produced a new pair of rabbits. See, the group of rabbits produced will just be one pair at a time. So we get a new pair, so now you're at 2. And then it takes a month for that pair to mature, but the next set of rabbits is already there, so you're at 3. Then you're at 5. Then you're at 8. Then you're at 13. How do you know what number comes next? You can see all those numbers up there. What's the pattern? Because this is what Leonardo da Pisa asked. Find the pattern. Do you see it? The pattern in those numbers. If you think you know the pattern, you should be able to give me the next number after 377. Try doing this. Silently in your head. Read them out loud, silently. So you're going to go 1, 1, 2, 3, 5, 8, 13. Then you go back again. 1, 1, 2, 3, 5, 8, 13. 1, 1, 2, 3, 5, 8, 13. Do that a few times. Do you think you see the pattern? Anybody think they see it? Okay, what do you think the next number here is going to be? $600 something, I agree. 600 what? 610. Excellent. That's right. Anybody else think they see the pattern? Okay, go back to the start. Just look at the first three numbers. Do you see a pattern? How many of you think you see a pattern in the first three numbers? Does it work for the next number? Okay, I've got three of you seeing it now. Again, go back and just look at the first three numbers. How did you get the 2? Think of that. And then does it work to get the 3? Does it work to get the 5? How many of you now think you see the pattern? Raise your hand. Okay. 4 or 5 of you. Okay. Keep looking. This is what mathematicians do. Stare at numbers until they see something. Sometimes it's late at night. Sometimes a couple of beers help. Okay. Maybe in the middle of the night you wake up, see it. Ah, another one. Isn't that neat to see it and go, oh yeah, how did I miss that? Okay, keep looking. Anybody else? You got to wait. I mean, you got to give some time for people to see patterns. Anybody else see it? Okay, good. We're getting about halfway. I'm feeling better. Anybody else? You got to keep looking at it. 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 3. Okay, somebody describe the, I hate to do this because you should wake up tonight in the middle of the night and say, oh yes, I've got it. But we need to make sure everybody has it. Okay, what's my pattern?
It's 1 plus 1 is 2, 2 plus 3 is 5, 5 plus 8 is 13.
5 plus 8 is your 13, and then your 8 and your 13 is your 21. So you just add the two numbers above. So I got the 21 by taking 8 and 13. Then the 13 and 21 gave me 34. Okay? We call those Fibonacci numbers. Now let's go back to the computer. My pine cone, courtesy of Ansel Adams. What do you see as you look at that pine? Do you see patterns? What kind of patterns are we seeing? Anybody? What do we call what we're seeing? Yes, it is spirals. Very good. We're seeing spirals. Now, let me use the mouse button here to help. Follow it around. See how you're seeing that spiral? A little bit hard to see, but you can. And then do you see a spiral the other way? So you see two different sets of spirals. One's easier to see than the other. So if I handed you this pine cone and I ask you to count the number of spirals, guess what you're going to get? A Fibonacci number. Pine cones have Fibonacci numbers on them. They aren't written. You don't pick up a pine cone and search for the number. You count. And that pine cone, I suspect, is a 5-8 or an 8-13, meaning you get 8 spirals one way, 13 spirals the other way. Now, pine cones aren't the only place we find these numbers, and it's intriguing. You find these numbers in something like a pine cone. Now, I made an effort to draw something on the board, so we're going to go to the board with my infamous artwork. And I don't do it well enough that when I get one that looks halfway decent, I'd like to frame it. What is it? Hey, I was successful. A sunflower? Uh-huh. Big sunflower. Where do you find big sunflowers like that around Modesto? The only? Oh, in your yard. Very good. If you drive out towards the highway on Kiernan, you pass Vela Farms, and sometimes along the road they will grow large sunflowers. Now, the largest one I've had about is this big, and we actually sat down with it, another instructor and I, and we counted the number of spirals on the sunflower. was fun in a sort of way, like hitting your thumb with a hammer. Guess what numbers we saw on this sunflower we did? They were Fibonacci, yes, and they were up into here. 233 and 377. It's amazing. You see numbers like that in a sunflower. Okay? The next one is not so good. And let's slide over now. And which way are you going to go? Okay. This is supposed to be a pineapple. It looks like an overgrown strawberry. It's like a pineapple. And do you see again the spirals in the pineapple? And if you go to the market, you can go to the produce counter and you can look at one of these. Now if you look too long, the produce manager gets nervous and will come up and say, is there a problem with my pineapple? Or do you need to know how to find out if the pineapple's ripe or not? You might not want to tell them that you're counting numbers. They may come and take you away. Guess what numbers we get here? Fibonacci numbers most of the time. But sometimes we get Lucas numbers. And on the screen, if you just look at a monitor for a moment, the right side of the screen you see a 1, 3, 4, 7, 11. Does it work the same way? 1, 3, 4, 7, 11. You see exactly the same pattern. But this is named the Lucas sequence. Now I sometimes refer to these as my Modesto numbers because George Lucas, same name. He didn't create them. These go back after the time of Fibonacci by quite a bit. Okay, so we have, let's go back to the computer. We have here a pine cone. So the next time you're in the Sierra, you have an opportunity to look for Fibonacci numbers. Now one of the things that we did at home, and this is sort of strange, this would only happen in a household like ours. If you go to the Sierra and you collect pine cones, they're all open up. They aren't closed like that one is. You know how they open up and the squirrels then tear off the little parts of the pine cone and get to the pine nuts and so on. So we found the pine cones and we wanted them to close up. So we boiled pine cones. So we got a big old pot of water and we put pine cones in it and made pine cone soup. Meaning we just boiled the pine cones. What happened to the pine cones is we put them in water and boiled them. They closed up. And you could count the spirals. And then I thought, well, these silly things are going to open back up if I don't do something. So I boiled them, dried them out a little bit, and then I varnished them. Put varnish on them. And put them up on the shelf so I could use them when I wanted. And one day, we were seated in the house, and all of a sudden heard this sounded like a gunshot. Whap! A pine cone had opened up. Broke all the varnish, needed to be reboiled. Pine cones, sunflowers, pineapples. Here's something for you to check. Do you have Fibonacci numbers as a person? Interesting question. So what I'm going to do now is look at that set of numbers again that we have on the board. We have a 1, 1, 2, and so on, right? We're going to go to there, Debbie. I'm going to ask you a question. Divide the smaller number into the larger number. So like 1 into 2 goes 2, right? 2 into 3 goes, and you get 1.3. And you just keep dividing the smaller into the larger. And we'll do that later because we aren't reviewing division yet. But if I keep dividing like 233 into 377, 377 into 610, I get a very special number, one of the most special numbers we have. Okay? And it is found in music, It's found in architecture. It's found in the way nearly everything that grows. And it's called the golden mean. So the number I have on the board right above the pineapple, and it is 1.6180339. Now we can actually find that number in an algebra class, and we'll be doing that in the algebra class that meets at 11 o'clock. Not today, but one of these days we'll be doing it. 1.6180339. That's a very special number, and it comes out of these Fibonacci numbers and the Lucas numbers. Now let me explain where you find it, and you could check if you want at home. You could go ahead. Okay, just have a seat if you're going to come in. Now, if you were at home, this is when you're taking your shower. You're going to go ahead and measure how tall you are. Now, if you know already in inches, that works fine. And then you want to find out how high your navel, your belly button, is from the floor. So you're measuring your belly button height, and you know your height. So you have two numbers. Divide the smaller number into the bigger number, and guess what you should get? 1.618. Your own special golden mean. People grow that way. Now, a very important artist, another Leonardo, used this number in art. Who am I talking about? Another Leonardo. Okay, related in artwork, but yes, Leonardo da Vinci. And I asked this question the last hour, and I've asked it a few times, and I'm always just amazed at who hasn't read the book I'm going to reference. The Da Vinci Code. How many of you have read it? Yes? No. Nobody? Okay, good. Enza and I have read it. Debbie? You're kidding. Okay, two of us. And there was only one in the last hour. Of course, I was in that hour too. But the Da Vinci Code is all about Fibonacci numbers. How can you not now want to read the Da Vinci Code? Okay, it's about Fibonacci numbers. Okay, interesting. I call it the McDonald's number. What's the relationship of McDonald's to my number?
The golden arches.
Yes, excellent. The golden arches, the golden mean. I know it's not very good, but I was impressed with it. Okay, the McDonald's number of mathematics, the golden mean. Nicely done, Debbie. Good touch. Now, 1.6180339 plus. The plus means more garbage to come. It never stops. Is there any other use for these Fibonacci numbers rather than just reading the Da Vinci Code, which you haven't done? The answer is yes. Let's go back to my numbers now on the front board. So whenever you're ready for that, Debbie. The ones over here. Okay. Now, as we go back to those, I've got two of them checked off. What's the importance of 55 in our society? The lack of answers tells me you don't follow the speed limit. 55 is what you should be driving maximum if you're on a county road, right? You're not supposed to do 80 there. 55. And if you hit certain sections on the highway, 55. Do some of the cars you're driving still have the little needle on the speedometer showing you how fast you're going instead of an LED readout? Okay, you can see the little needle go up. And it's fun to see it go. right? What do you see above a 55 on your odometer? Your speedometer, sorry, your speedometer. What number is above the 55? Most cars. Usually an 88 or 89. What does that represent? How fast your car is going in what? Kilometers per hour. Very good. So if you're going 55, you're doing about 89 kilometers per hour. That's how they measure speed in Europe. Kilometers. Most places other than the United States. How long is a meter? And a kilometer means just 1,000 meters. How long is a meter, roughly speaking? If you were to tell somebody, a meter, how long is it? What would you say? You wouldn't. Okay. Well, let me give you a way of answering that question. About 3 feet, right? This is, and okay, that we've zoomed out enough. This is called what by many people? Yardstick, ruler, but a yardstick. It's supposed to be 36 inches long. This one's 39 inches long because it's a meter stick, not a yardstick. So the question, what is the relationship between a meter and a mile, or a kilometer and a mile? So if you're doing 55 miles per hour, how fast are you going in kilometers? We said 89. Well, 1 mile is 1.618 kilometers. So if you go ahead and you see a sign on the road that says it is 55 miles to somewhere, you know it's about what? 89 kilometers. Now, we make a drive these days more often than I'd like during the summer because we end up having to fly to see our kids. We have kids in Texas. We have kids in Washington. We have parents in Missouri. And I have family in Iowa. So we fly around. And when we do that, okay, as we go back and forth to the airport, we fly out of Sacramento because I don't like hassling the Altamont Pass. How far is it roughly from here to SMF? Sacramento Metropolitan Airport. About 90 miles, about 89 miles. So how many kilometers is it? Back to my numbers on the board. If it is 89 miles, how many kilometers? 144. Now that's a real perk, an advantage, being here today. Now somebody says, I went 144 miles, or I'm sorry, I went 144 kilometers per hour on the Autobahn in Germany this summer. And you aren't impressed. You say, hey, 89, you can do that in I-5. Okay? Just before you get picked up. Very useful, this set of numbers. Fibonacci numbers. Now, if you look at Lesson 2, and one of the problems in Lesson 2, because we've been adding, right, to get these numbers. We've been adding in our head. And if I go to Lesson 2 with addition, and I look at page 17. So you go to page 17 in the book. And let me change this, Debbie. And this is what we're talking about. I'm going to try to get this. There we go. An interesting sequence. Leonardo da Pisa, 1206. There's your 1, 1, 2, 3. And the pattern 3, 5, 8 is disappearing as we watch. Okay? Now, what I ask you to do there, I just give you a few of the numbers. I ask you to get the next 10. Well, how many numbers do I have up here? Well, as I look at my list, I think we're down around 14 or 15. Here's what I want you to have done for this problem tomorrow. I went up through the 25, the first 25 Fibonacci numbers without a calculator. And that's part of your solution. And you can use the side of the page on page 17 to write them. So you start with 1, 1, and go to 2, and I went up to the 25th Fibonacci number. You're adding, and this is reviewing addition. That's what it's all about. Okay? Any question there? Now, what you're doing is finding a sum of two numbers when you get the Fibonacci numbers. So when we said 5 and 8 was 13, you found the sum, which is meaning that you're going to add numbers. Now the question, when you add numbers, what are some of the techniques you can use? Some of the best ways of going about it? What would most of you do if I handed you a set of 50 numbers and said add them up? What would you be inclined to do? Oh, come on. Now you're not being honest with me. I give you 50 numbers and ask you to add them up. I would suggest that most of you will hunt, even if it takes an hour, to find your calculator. Now, if I have you in a class and no calculators and I say add them up, yeah, you'll do it. But most of us avoid large sets of numbers without a calculator because we hope to get better answers using a calculator. Now, I just want to caution you. First, in this class, I don't want you using a calculator right now. And if you do use a calculator, understand that you can get a wrong answer with a calculator because it's very easy to reverse digits, press the wrong button, just do silly things. Now, in the stat class, statistics, which we do at 7 o'clock in the morning, I often have students using the calculator to enter numbers. And I'll ask them to get me an answer, which means basically I'm asking them to add the numbers. 30 students in the class, we can get as many as 15 different answers. Every one with a calculator. Because they entered the numbers wrong, or they pressed the wrong button. Not sure why, but we can get a lot of different answers. So when I talk about techniques, using a calculator is one. Hiring somebody to do it for you is another. That's called an accountant. And they will charge you $75, $100 an hour to add your numbers. But there are people who get paid to do that. Now, an accountant does a lot more with numbers than that. I don't mean to indicate that they are restricted just to adding numbers. But that's a person who does work with numbers on a daily basis. Well, what techniques can we use? One is grouping by tens. And so we're going to go to the other side of the board now, Debbie, where I have some work. And this is a problem where I'm grouping by tens, just to illustrate it. Now my original numbers, and I'll rewrite those so you can see them, I had a 71, I had a 64, a 38, and a 42. Now this technique does not work on every set of numbers. Now what most of you would do is probably add up this column and make a carry and do it that way. It's a typical. So you'd say 1, 5, 13, 15, write down the 5, carry the 1. But a better method is to group by tens when you can. So I see this 8 and 2, and it is 10. 5 more here, that's 15, and it was an easier answer to get. Now do you see groups that I can do here to get tens? Okay, the 6 and the 4. What else? Do you agree with the 7 and 3? If I'm blocking your view, just look at a monitor. You see the 7 and 3 also. So I have the 7 and the 3, and that's another 10, right? So now I have 10 and 10 is 20, and one more makes 21, and we tend to make fewer mistakes that way. Now that's grouping by tens. And I have some problems in the homework for today where I want you to group by tens. So I'm going to go back in a moment here, Debbie, to the document cams. So I don't know which camera we're on at the moment. Okay. And in this case, what I want to do is go ahead and reference a problem where I've asked you to group by tens. So if I look at number 4, and I just have, let's see, I need to come up just a little bit there. Okay, let's look at that set of numbers. Now, in that set of numbers, I want you to group by tens. Now, just visualize it for a moment. In the right column, what would you do if you were grouping by tens? Just looking at that now, what would you do? What do you see?
6, 4, 8, 2.
Okay, the 6 and the 4. And what? The 8 and the 2. And then what do you see in the left side that you could do grouping by tens? Okay, the 7 and the 3. And then what? At the moment, okay, because you had to carry a 2, you'd have a 4, 2, and 2, 3 2s and a 4. And it works out rather nicely, correct? Now I want you to be able to show the same kind of thing I did in the board, where you circle the numbers and group by tens. Okay? There are other techniques. One of them I tried to illustrate a moment ago. I'm going to do it up here with this Lucas sequence. So let's go to the Lucas sequence. Okay, I'm going to wait for Debbie. She's moving cameras around. I tricked you, right? You thought I was going over there for the moment. Now I'm going to look at this Lucas sequence. And I'm going to ask you a question. If I just added these numbers, I want all of them added up. Is there a technique I can use to make it easier? And the answer is yes. It's called a low stress method. So we're going to call it low stress. And so what I'm going to do is run a subtotal on paper. So 1 and 3 is 4. 4 and 4 is? Now you're giving me the next number. I just want to keep adding. 4 and 4 is 8. Then I add 7. So I'm just looking at these two numbers. 15. Then I look at these two numbers. 26 and so on. Now that's called a low stress method. Now I'm going to illustrate it with another problem I have over on the other side of the room, which is where Debbie was wanting to go earlier, which would have been well done. So on the transition, Debbie, what camera are you on now? Okay, you're on this one. I'm going to go ahead and let you just keep looking at this as I walk off camera. So folks who are watching this would be able to focus on that while I travel. And I have two problems over here. Let's look at the numbers. Write these numbers down on paper for me on your notes. You have a 22, a 39, a 25, 63, 14, and 47. So I'd like you to write those numbers for me. And again, you can look at the monitor and see them just as easily. So we have those numbers written down. Now I'm using this method to add each column. So let's see what I have. I have a 2 and a 9. And that gives me an 11. So I keep the 11 in my head. Or I write it down. Writing it down makes less stress. So what's 11 and 5? 16. I write down the 16. Then I add 3 and get 19. Add 4. Get 23. Add 7. Get 30. Write the 0. Carry the 3. Now what I'd like you to do is the other column and see if you can make it work. Now I'll just step off camera so you can do that. So what you're doing is that left column, you're adding the digits. You're adding the digits, low stress. Just keep it over to the, there we go. Did you get that same result? You got the 3 and 2 is 5, the 5 and 8, or 5, oh, I got a 5 and 3. 5 and 3 was 8, the 8 and 2 for 10. Now, the next middle of what you see on the screen, go from the bottom up. See if you can get that to agree. You're going to start from the bottom and go up rather than the top going down. Now again, just leave that on the screen. Now, this is how you check your work. Reverse, go from the bottom up. So when I took the 7 and the 4, I wrote 11. The 11 and 3, my 14, and so on. Okay? See if you agree. Again, I'll go off camera. Now this is called the low stress method. Once you've done that, then I'm going to ask you to turn to page 16. But let's make sure you have that so far. Is there any question in what we did there? Okay, let's go to page 16. I have that on the document cam. Question? I'll just pass it forward if you would. That's the roll sheet, so if you haven't signed it, it's going to be passed up. Sign it if you haven't, all the way towards the front. Now here is page 16. Now I'm asking in the directions to do the low stress method. Now what I expect to see on your paper, and I need to make this rather clear to you, when you go ahead in the low stress method, I want you to write in the book, I want to see your work, because after we've done 6 lessons, I will collect the books from you, and I will expect to see the work done in each exercise. And if I don't see that done, then I'll return it to you with the notation of no grade. If it's all done, I autograph it with my name and date and say, okay, 1 through 6. So on this problem, I want to see, starting from the top going down on the right side, I want to see subtotals. And then I want you to check your answers starting on the left side going up to see if you get the same total at the end. So you reverse your arrangement. Now this is all done without calculators. This is the low stress technique. Now I'm going to ask you a question. Is it as easy to put things together after you've taken them apart as it was taking them apart? Occasionally, it may be as easy. But if you take something apart, you try to put it back together, reversibility is sometimes a lot harder to do. So if you drive from here to San Francisco and then try to get back, oftentimes you end up in Stockton. Why? Well, as you go from here to San Francisco at the Mossdale Y, you don't recognize that when you're coming back from San Francisco, you have to make a decision to go to your right or your left. If you go to your left, you end up in Stockton. If you go to your right, you end up in Modesto. Reversibility is tough. So if you're used to taking sums coming down and I ask you to reverse the process, it may feel awkward. We're going to use that technique in the next lesson on subtraction to avoid borrowing. So I warn you now, we're going to subtract different than you probably learned. What is the difference between Math 10 and Math 20? What is the difference between a course and where we're reviewing in arithmetic and a course where we're doing pre-algebra? And sometimes the answer to that question is very subtle. I'm going to show you a problem and argue that this is a pre-algebra problem. You tell me why. What's pre-algebra about that as opposed to arithmetic? What's different? You tell me. What makes it pre-algebra? And I do a lot of this in the book. What makes it pre-algebra? Anybody? What? Well, I don't actually have a formula, right? I mean, I've asked you to recognize the word sum. Okay, I'm going to come off there for a moment and come back up here. Good. This is the problem above. That's arithmetic. This is the problem below. That's pre-algebra. And indeed, the difference is vertical versus horizontal. In pre-algebra, you see a whole lot of numbers done horizontally. And most of the time, we're used to doing them vertically. Now, I've written this problem on the side board. And let's go to that and see what's being done here. And this is a rather important place to avoid mistakes. Yesterday, we talked about place value. The first digit on the right of any number is called the ones place. So that 3 tells you you have 3 ones. This 7 tells you you have 7 ones, and so on. So what I do is rewrite these so the ones place lines up. Now, I put decimal points here because technically, after every number, there's a decimal point. We don't usually write it unless we want a digit after the decimal point. But it's there. It's the unseen decimal point. So I lined them up. Now you have a choice. You could do grouping by tens. Is there anything that gains you something here grouping by tens? Only one, the 7 and 3. So in this case, you might want to do what? Do the old-fashioned, add the columns, show your carries, and get your answer that way. That is expected. I don't want a calculator used here. Is there any question in that problem? Okay, let's go back to the document cam. Remember, that's the way the problem was originally written. Now, the question, talking about algebra, what is the one thing that messes up students in an algebra class more than nearly anything else? Any guess? Okay, it's the very thing I'm asking you to do right now. Arithmetic. Students in an algebra class typically have trouble remembering how to do arithmetic. Part of the problem, they spent most of their life recently using a calculator. If students could do the arithmetic they're supposed to, algebra would work a lot better. So the question, how fast do I expect you to be able to do that? And there's a problem in the exercise that you need help doing, and I'll explain why. So let's look at one more problem, and that is on page 15. Okay. Now remember, I spent a little bit of time trying to argue with you, not against you, but with you, that we try to lower the stress. So here's an exercise on page 15. And I ask you to do this with 1 minute. Now that's where I mean that you need help. So in this case, somebody times you. In 1 minute, there are 30 parts to this problem. That means 2 seconds per number you write down. If you know your addition facts, you should be able to do that fast. If you really know them well and you're fast, 30 seconds for those 30 problems. Now, most people in 30 seconds start feeling the pressure and stop. It just gets, not going to deal with that pressure. But you do need to practice finding answers to addition problems quickly. We're going to do the same thing in subtraction, multiplication, and division. It's the same kind of thing that at about the 3rd grade turned students off because they were expected to do things quickly under pressure. That's the same expectation here, pressure and speed. And if you're thinking of going on, pre-algebra and algebra, it's the one thing you've got to do. Practice, practice, practice. Well, let's turn to page 185. 185 at the back of the book. And on this, we see Review Test 2, page 185. You're going to write the answers to this review test in your book, and it is due tomorrow morning. You're supposed to come in at that point with the exercises done also. So if you don't have materials right now, you're getting behind. And you can afford to get behind a little bit, but not too far. Now this, again, will be a case without calculator. And I would like you to try to do this on your own without getting together as a group to do the review test. I encourage you to get together to do the exercises as we go along. And the same for the orange book. A reminder that the orange book I need to have in your hands by Thursday, because that's where we're going to go on Thursday. And you need both books because we're going to continue this pace, a lesson a day, and the early ones you can catch on pretty easily, catch up, but as we go along, it gets more difficult. I would typically, again, return to you review test 1 tomorrow. I will delay that because I have people who do not have it done and need to get materials. Remember, on the Fibonacci problem, you're going to give me the first 25 Fibonacci numbers. That is the problem number, what was it, 5? I'm trying to remember the problem number on page, what was it? Let me get back just so I remind you again of what you need to do. That is page 17, number 6. So on 17, number 6, you need to do that.